Okay. So we're going to refer to this for the whole course. There's all different kinds of numbers, and we want to break them into categories. Just like we categorize food, there's fruits, there's vegetables, there's breads, there's, all different kinds of, you categorize cars. There might be a subcompact or a truck or a van or whatever. We usually break things into categories to kind of help organize them. Okay? So let me just give you a couple numbers here. And let's say different one. Okay, just a couple examples. Anybody know what the smallest category of numbers is? What's like the first kind of category that you start out with? You might want to take a guess. Like, what did you learn in, say, in elementary school? What numbers do you start out with usually? The whole numbers, right? You start counting stuff. You go 1, 2, 3, 4, 5, 6. Okay, so you start out with your whole numbers first. That's our smallest category. So I'm just going to put a little circle here. This will include the whole numbers. Okay? I'm going to include 0 in there too. Okay? Then if you get a little bit more advanced, what do we want to add on to that? Okay, you're right, Luke. We'll get to that in just a little bit. We'll get to that in a little bit too.
Negatives.
Negatives. Let's add on the negatives. Anybody know what you call those? Integers. Thank you, Luke. Integers. Okay. So if you think of it, maybe most often when you've seen a Venn diagram, we call it, maybe you've seen something like this, where the two circles overlap just a little bit. But here the integers totally swallows the whole numbers. Just to give you a little example, let's say we were talking about this morning, Mr. Nails was talking about, and the kids in the video were talking about joining clubs and activities. Let's say something like, let's say you have some people that are in DAT, and let's say some people that are in cross country. If your Venn diagram looked like this, what are these students in here are in both, okay? If I drew it like I drew this down here, what would that be saying? Everyone in cross country is in DAT. So that's what I'm saying down here. All the whole numbers, like when you have like 4, you can also call that an integer. So the whole numbers are included in the integer. So all the whole numbers can also be called integers. Does that kind of make sense? Okay. So that's what I'm talking about. And yes, you're going to need to know this. Yes. You always want to write your notes down. Oops. I have to recalibrate this a little bit. Okay. Now, like you guys mentioned, we added on the negatives. Now we want to even add more. It's kind of like you start out like with your number line. You first learned about the whole numbers. Then you added on the negatives. Now we want to start filling in some spaces in between. So we brought in fractions and certain types of decimals. So anybody, I know I've talked about this in geometry, if you have me for geometry, or anybody remember what you call, what's another way sometimes when you see a fraction, like if you see something like this, I could also, what sometimes do we call that when we write that like that? Or if I wrote it, you'd probably recognize if I wrote it like that.
Ratio.
A ratio. So we call them, what's the next branch? What kind of numbers? It starts with ratio, and it's rational. Very good. Okay. That again swallows both of these. So in other words, the number 2 is a whole number. It's also an integer, and it's also a rational number. The definition of a rational number, if you a rational number is any number that can be written as a fraction. Any number that can be written as a fraction. So we got 1/2, 3/8. What if I did something like, 0.5, that's the same as 1/2. If you did, anybody know what 0.125, what fraction that is? 1/8, good job. Yep, very good. So if you can write it as a fraction, it's a rational number. Now, guys, when you do also, if you do something like 1/3, we talked about this when we talked about the probability. What's 1/3 as a decimal? That probability. Okay. 0.3 repeating. So rational decimals. Rational decimals, what 2 types are there? Like you guys said, 1/3 was 0.3333333. 1/2 as a decimal is 0.5. Is there anything after that? You could put some zeros, but what were you going to say? We'll talk about that later too, but there's 2 different types of decimals there. They're either going to do this or they're going to do this. They're either going to this one just we sometimes say terminates. It either ends, it terminates. Like 1/2 is 0.5. That's it. There's nothing after. It's not 0.525 or it repeats. So another thing I want you to remember about rational numbers is that the decimals either end or repeat. Just to get some more space on here. Decimals end or repeat. So what other kinds of decimals let me just erase this off here. What other kinds of decimals are there besides ones that end or repeat? What also could a decimal do? Okay, so if you do something like, pi is I always like that example. If you look at that poster back there that I have up on the wall. If I kept that going, is that going to end? Is that going to terminate? Nope. They can, I don't know how many digits they have currently, but in 2010, but I think there's probably millions of them. It just keeps on going. Is there ever a pattern? Nope. You could take that poster and I could put out 1,000,000 digits. Yep, I could wrap it around the world. There's never going to be, you could never take any sections and find any repeated patterns. There's no patterns. What kind of decimals do we call those? No, you're right, Luke. They're never ending. Everybody remember the technical math term? You're right, they are infinite. They keep going. We call them, if they're not rational, if someone does something that's not, if they do something, if somebody's not making sense, you might say they're being irrational. So that's the term that math term that we use for those words. So another group of decimals over here is irrational. So what two things do you know about irrational decimals? Just the opposites of these. They don't end and they don't, good, they don't repeat. Okay. What are some examples? We gave one example, pi. What are some other examples of irrational decimals or irrational numbers? Yes. If you not all square roots. What's like the square root of 4? 2. That's what kind of number?
Square number. Even.
2 is a whole number, right? Or an integer, or a rational number. When you do like the square root of 3, I could do, just so you can see it. Let me just bring up my calculator here. I think, here we go. Well, just so you can actually see the numbers. Okay. There's the square root of 3. They didn't show, you could keep going. But, like I said, if it showed more digits, it's not going to end. There's no repeating. You're never going to see a 7. There's no repeating pattern. No little block of this gets repeated again. So square root of 3 is an example of an irrational number. Doesn't end, doesn't repeat. Okay? If I did something like, let's say I do a fraction. Say 1/19. Oops, now I want, let me get that approximate. Okay, there's decimal. Let's see. Just raise your hand, Luke, if you have a question, okay? Can you see any repeating pattern there with that one? 0, 5, 2, 6, 3, 1. I don't see any repeating pattern. Could it maybe be irrational? What do you think? The fraction 1/19? What do you guys think? Could it be irrational?
It's irrational.
Yeah, it's not. No, it's not.
Yes.
It can be written as a fraction.
I'm changing my answer.
Very good, Rosie. It can, I want you to remember, if you can write it as a fraction, it's rational. Think a ratio. So sometimes it's hidden. I'll tell you, this one doesn't end, That if I could push it, if I could get the calculator to show more digits, it's not going to end. It's going to keep going. But since it can be written as a fraction, since it's rational, what has to be the case? I'm making you think deep on the first day. There has to be a pattern. It has to be repeating. And actually, I don't have my sheet right here, but I can't remember what the repeating pattern is, but I think, let me just see if I have it in my little sheet here. I didn't write that down. Let me just look here real quick. Okay, here we go. Actually, so it's pretty crazy. This would be hard for you to see on your calculator. 1/19th, Rosie was very good. She stuck to it that it is a rational number. Anything you can write as a fraction is a rational number. But even though we couldn't see it on the screen, since it doesn't end, it does repeat though. It's got 18 repeating digits. So if you had a big enough screen, when you do 1/19th, actually I'll write up here so that you can see it. If you were to do 1/19th, it says 0.05. This whole thing, I'll just write it on here, it's going to get repeated again. It's going to go 0, 5, 2, 6, 3, 1. Kind of get the idea? It goes in blocks of 18. Okay? So these are just some common ones. I mean, 1/29th, if you do 1/29th, that's a rational number, but it actually has this block of 28 numbers. Pretty crazy. So even though it kind of looks like pi, it looks irrational when you look at it on your calculator. Since it can be written as a fraction, it's not, it's rational. Luke. Most of the, yeah. And it doesn't necessarily have to be prime. I mean, you could do like, I'm trying to think, any number that's not a perfect square. Like, say, it's square root of 20 even. 20 is not a prime number, but it'll be irrational. Does that kind of make sense? But if you do like square root of 25, that's not irrational because that's just 5. Yeah, that's a good question. Okay, so let's go back to our notes. We've got, all right. Now we'll talk more about this later. I'm just going to have you write it down so that you have it. The club or the branch or the category that includes both of these. So you can do one more category, and that's real numbers. We're going to talk in Chapter 5 about imaginary numbers. But I know that doesn't make sense now. It doesn't have to. But mainly what I need you to know right now is I need you to have clear the difference between rational and irrational. Okay? So what I'll do is